Hello, I'm Verdi Arbusto, and this is the Schumann Resonance Harmonics channel on YouTube and on Facebook. Thank you for joining me. And if this is your first time here, welcome. Be sure to like, share, comment, and subscribe. And the way to keep your favorite content providers up in your recommended feed is to go there and do all those things like share, comment, and subscribe. And so, knowing that, please do that to this video. I would greatly appreciate it. Please comment, especially because I want to know if you have the material. I would like to know if you understand the video, if there's things that don't make sense, if the presentation, like whatever your thoughts are. I read all the comments. I don't always reply back to all the comments, but generally speaking, if I put a little heart next to it, I've read the comments. I don't think that all of them are worth or need me to comment back, but I do tend to, any questions I'll respond to. So if you have a question, especially if it's a specific question, leave it in the comments. I really want to know, make sure that you have this and you understand this. All right, because I'm not doing this because I need my ego boost. I'm doing this because I want people to understand what's going on with the Schumann resonances and the equipment. Okay, so with that out of the way, it's like Sunday the 24th now. It's early in the morning, but I wanted to make sure that I did these because this issue is still relevant, and I still see people posting about this very thing. So as long as it's relevant on social media and on the feeds on YouTube and wherever else, it'll still be relevant because you're going to be seeing this again. And so if it was relevant, a couple days ago, it's going to be relevant again. So it's not like there's a time rush on getting this done. Something else I want to mention at this point that I don't think I've actually mentioned before, or maybe I did once, that my videos and my presentations are kind of in-depth analysis. And even though I try to have the most current version, the most current report of the Schumann resonances up on the screen, it can actually take me a few days to get the finished product out because I do a lot of research. And that's what this is. That's what makes me different from everyone else that I know of, that I can think of, pretty much everyone else, is I read up exclusively on the Schumann resonances. And so what makes my review different is that I'm giving you the full totality of the elements that go into this and not a line of rhetoric of how our moods and our feelings are affecting this, right? That's pretty much what you get the majority of what you get everywhere else is people look at the Schumann resonances as a mood ring, I think. I kind of use that analogy. So because I look at the facts, I look at the data, I look at the surrounding elements to it, I'm that kind of a show. I am ascension based, most definitely. And you need to know the difference between the good, solid material and the airy-fairy, woo-woo. Right? That's my view. I have already been through an ascension once. Right? I'm not here to tell you what to believe, how to believe. This ain't about that. What I'm here is to give you the facts and the data and information that supports the belief. Behind all belief, if you want something to be true and accurate, then, relative to the resonances, then come with me and we'll figure this out together. But this is not a place for the belief in Schumannism and a lot of the technical scrying. I think that's the best way to put it, technological scrying of the equipment, all right, or the readings of the equipment, I should say. All right. Okay, so with that disclaimer said, this is the second video in a series, kind of a kind of telescoping series, I would say, where I'm going to be looking at this issue of the huge data spikes at in Italy, Cumiana especially, but Italy as a whole. So as we move onward and upward, excuse me, I will be giving a broader view of Italy as a whole here at this point. All right. Okay, so where are we? Okay, so where we are at is, hello. Where are we? Okay, so where we are at is here. I'm sorry, trying to find the thing here. All right. Trying to scroll it down. Okay, so where we are at is we're looking at this right here. All right. Let me pick a color. All right. So brushes. All righty. Okay. All right. Right here. All right. Okay, I'm back. All right. Well, I just need to say this, that these videos can be more difficult than they look. They can be a little easier than it looks sometimes, but then it's as prepared as though I may be. There's always something that happens while I'm doing this. I didn't set it back when I was testing it, or some bullshit, or the thing is on the wrong screen, or whatever. All right. So, all right. So, thank you. Thank you for letting me vent there for a minute. All right. So, we're 7 minutes into this. All right. So, this. All right. So, the first thing here is the time and the date. We're looking at this. All right. So, that tells us it's on the 22nd. Okay. And then this is the 15,000 hertz field. Okay. This right here is our decibel meter. That's decibels. Boop. Equal power. Number. Boop. Okay. So, when we look at this number here, and they gave us a value of 6,000, remember, which is right here. Okay. And that was disclosurenews.com had given us that 6,000 number, where they had perceived it to be 6,000. All right. But you can see the peak goes more closer like up here. And what we're looking at, and that's closer to like 8K. And this is 6K. And again, we are on the VLF monitor here. All right. So we're looking at the peak here at this particular time. Now, I want to bring something to your attention. Do you see these right here? These are interesting. It's an interesting stacking pattern. Okay. I'm not certain. Okay, let me just say this. I'm not absolutely certain, but I am pretty sure that this is registering a transverse wave, which is a wave that moves this way. Okay. There's 3 axes. There's the horizontal, there's the vertical, and then there is the moving that way. Okay, so, right, there's up and down like that, and then there's swimming like a fish, and then there's the horizontal. All right, so there's these 3 axes that varying combination between the electric and the magnetics to the transitionary phase between the two of them. And there is also the, how do I say this? The pulsating of the standing wave. So there's actually 4 different types of movement that the waves can do. All right, so remember that. So this is just a flat cross-section that you're seeing based on a snapshot. It's a snapshot based on one particular second, one particular moment in time. It's scanned so many times in a second. All right. So this all right, let me go back here. All right, so those are our transverse. So that is a type of frequency movement that is different from the horizontal hertz, which is a cycle per second, based on it bouncing up and down from the earth ground, up and down, up and down. Okay. So the next one, all right, so this one here is measuring the, that's 1.5 right there. Well, I should say, whoop, let me back that up. All right, so this is 1.5 K H Z. Okay, all right, you can't really see that. All right, so this is a little different scale. So you see a different magnitude, different section of it than the other one. All right, some things will register more in this. They don't go up that high, right? You know, normal solar radiance, we'll say, will fit within, you know, this scale here. Normal. So when you have a big strike like that, up there, right there. So when you have a big strike like that, that tends to mean it's more local than solar forcing. And by solar forcing, I mean solar radiance that comes down in layers. You have to remember that the sun's, how do I say this? That we have 2 circuits. There's the upper DC circuit, which is the direct line of the sun to the magnetosphere and then the ionosphere. Okay. But a lot of the solar radiance gets caught up in the ionosphere. Okay? And it doesn't come directly to us. It comes through layers. It comes forcing. Right? That's when I use the phrase solar forcing. So it comes down from the top like pancakes. Da-douche, 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 da-douche. So that is a type of frequency that is a plasma-based type of frequency, which is not a cycle per second. Okay. It is closer to a velocity, but there is a different, I don't know how to explain it. It's a different motion. It's a compressing motion instead of a rolling motion. Okay, I don't want to explain more than that because I may complicate it. But if you can picture the balloon, a compressing motion that you're condensing, and heat and you're condensing it, and the molecules will speed up. The frequency increases because you have compressed it. Okay, but that's one way of increasing the frequency of it, and that is more or less how the resonant frequency of the Schumann resonance increases is through that compression of the ionosphere, like a balloon. You compress it, and it kind of excites the molecules up. Okay, so when we get solar bursts, it pushes that bubble around us, tighter in around us, and the harmonics increases. Okay. So that gets registered up to a certain, as a certain, how do I say this? That gets registered usually within a certain range within the Schumann resonances. Okay, within the VLF, put it that way. Not within the Schumann resonances per se, but within the VLF range, which is outside of, the VLF range is outside of, strictly speaking, the Schumann resonances. Okay. So both of these, it should be known, both of these, where am I? Over here. A, channel 1, this is 1, this is 2 here, okay. So both of these are outside of, significantly outside of the range of the Schumann resonances, which end at approximately 46 hertz horizontal frequency. Okay. Okay, so this is showing you these interesting patterns here. All right, so the next one, we have the Marconi antenna and geophone. All right, this one here, onward and upward here. Okay. Now what it's telling you is there's amplitude, scale, and then there's 2 channels listed below. Okay. So this is what we are looking at here. Below this is there's 2 channels. Okay. The first one, it says channel 1 is a seismic meter. Okay. Channel 1 is a seismic meter. Frequency range 1 to 30 hertz with the top spectro. All right. So that's right here. This is the top. Spectro. Okay. All right. So this one right here, actually, hold on. Sorry, this one right here is your top spectro, because that goes up to 30. Okay. So this right here is your intensity meter. Do you see where you have this? Oh, no, I don't even want to get into what the top one is. All right. Let me just kind of, I'll save that for the more advanced class. All right. So what we're looking at, what we're looking at is not the top one, but the second one down, what they're calling the top, this is the spectrogram here. This is not the spectrogram. All right. And once again, we're looking at the date here. This is Cumiana. All right. And that shows us on the 22nd. Oh, I just went over it. That shows us on the 22nd. All right. All right. So this one here is 30 hertz. So, but this is the seismo. All right. So that and that are the seismo. Okay? Just so we know. You can sort of read that. All right. The yellow is hard to read on the white, but all right. I'm telling you what I'm saying as well as I'm, most of this is in color. That's why I'm picking the yellow. So I apologize that the yellow on the white doesn't look that great. It's not a high contrast. All right. I'm sorry, but that's why I'm saying it as I'm writing it. So the top is, this goes up to 30 hertz, and both of those are seismos. All right. Okay. So it's very important that we look at the seismo. Now, the seismograph is a meter that detects the Earth's shaking. Remember that. It's a motion detector, basically. Motion sensor, motion detector, but it's of the Earth's motion. Okay. So, as we see, I had pointed this out early, so as we see, this to that, and that to that, and that to that, and you see all this activity. So from this point on, you see all this activity. All right. And so it's obvious, right? If you know what that is, what you're looking at. This is the seismometer. This is where the Earth is shaking, right? It's telling you, right up there. Seismic monitor. This is, after all, a station dedicated to picking up earthquake frequencies. They spent all this money on earthquake detection. Keep that in mind. This is why they spent all this money on the station, for detecting earthquakes to save lives. I cannot underscore that enough. They invested all of this money in saving lives, and not for you to look at this as a mood ring. I just humbly offer you that, okay? Right? This information here is for detecting earthquakes, why it's so important, right? It's not for you saying, oh, I had a headache. Please, spare me, okay? This here, if you're in America, anywhere in America, this does not apply to you. If you're in Italy and you have a headache, okay, you're in Croatia and you've got a headache, yes. But the fact of the matter is, you got bigger headaches than just, oh, my invisible symptoms. Okay? I humbly submit to you. So that's what this top one is. And the bottom one, this one here is, all right, you see the 50 hertz line. That's a 50 hertz line. All right. So you're seeing more of what you saw above, okay? And you're seeing a little bit more detail of the bottom end. But what we're looking at is we're correlating the Earth movement with, you know, on the scope, just on the scope, for you technical scryists out there who are so big on the scope here. This is, you need to see this, right? One scope, two scope, all the scopes, all of them together. It's very important you see all of the data together instead of just the little part that you want to see. You need to see all of it so you get the full picture. And that's what I'm doing here. That's what I'm presenting. That's what you get here, is the full picture of what you're seeing. And so then they're telling you about their frequency resolution of 84 megahertz as the frequency resolution. Okay. And it tells you something that's really important here. I'm going to zoom in on this so you can see it. Really important. Okay. It says, as the receiving station is placed not too far from an industrial area, sometimes strong tones are detected by geophone sensor caused by mechanical machine 1 kilometer far from here. Okay? Let me make sure that we see this. And I want to make sure that you see this. So, oh, zoomed in on it. It's way down there at the bottom. Alright, so sometimes strong tones are detected by... Alright, so if you look past the... Wait, hold on. I'm a nudge. There we go. Okay. As the receiving station is placed not too far from an industrial area, sometimes strong tones are detected by geophone sensor caused by mechanical machine 1 kilometer far from here. Okay. So now that we see that, we verify it. All right. Let me zoom out. Okay. So there's two things that we're coming across, or a few things that we're coming across here. One is the correlation, the clear correlation between seismic activity and the peaks, the crazy peaks at 6,000, over 6,000. They capped it off at 6,000. It's over 6,000. But that's just in the, again, you have to look at, here, you have to look at this. The color here is the decibel, again, this is the decibel. Okay. Decibel. So right there, at this point right here, right there, you see negative 50. So what that's telling you is that it's not giving you a value per se. That's just telling you it's pegged to the meter. It's beyond what the meter, literally, I mean, that's pretty much what that is that's where that's at. So anything that's over, actually 60, negative 60, is going to be, you know, in the red. Okay, I think that's what I'm looking for. I was going to say pegged meter, but it's in the red. Okay, so. All right, so we're back to here. This is the daily, more, you know, it's more of the same thing, but it's a day by day. So it's, and again, it truncates it. It cuts it off at 40 instead of the 105 that it normally is. All right, so we see here, we've already looked at this, but we see little spikes before that. This, the one that you saw, is 8 hours. It's only the last 8 hours. The big one there is 8 hours. This one here, however, is all day. So you see little activity in this line right here. That's 7.8. All right. All right, so that's 7.8 hertz. All right, so just so we have a scale of where the resonances actually are. All right, so we see a little bit of a peak here. Let me go back to my yellow. Actually, that might be all. So we see a little peak here. Then we see these other smaller guys here. Okay. So if it's seismic, we should be able to pick that up on the seismograph. All right. So I've talked about this. This is, like I said, a multi-day view. I've talked about there's a data void here, and then the day before that, the previous day before that, there was another data stripe, another void in the data stripe void. And so my suspicion is that they took the machine offline to do some maintenance. Okay. So I'm suspecting this is maintenance. Okay. All right. So we've been talking about, let me find my little thing. All right. So this right here, geophon. All right. So again, once again, our date here is on the 22nd. We're matching that up. And this is the 1800 UTC. Okay, that's the time they're giving it. All right. So what we're looking at, this is geophone. This is the one that does seismic meters. And this is telling you from this point here on the hourly strip. All right, so these are hour by the hour. All right, so these would be the last hour before this right here. Okay, if you understand that. So each one of these strips represents an hour. Okay, so this is 1, 2, 3. This is 4 hours before that current. All right, so you can see, the current would be here. At this point, you can see 4 hours before that. Okay. This is a different time scale altogether here. That's 16, that's 14, so that's 4 hours right there. Okay, showing it right there. So you look at some of this pretty intense activity. Where are we? Doop. All right. So some of this intense activity here. Right? This is earthquake. This is earthquake. Seismic. This is earthquake activity moving. Okay. Again, you got to remember seismic. Boom, right there. All right. So this is the last 4 hours here. All right, 4 hours. Okay, that's me. However, okay. So, all right, so right in here, where am I? Hello, where am I? Here we go. All right. So in here, I'll include that because it's in the water. All right. So all of this in this area here is where it's shaking. So Cumiana northwest is right there. Boop. X marks the spot. So it's getting hit from Germany, France-Germany border over there on that one side, and then Italy on this other side. Okay, this is contemporary. This I took at the same time. You know, I did all this together, and I don't have a time. There's no time signature that I could give you where it showed you right then on the spot. But this is the, like I said, this was the capture of all of it at the same time. You know, I do these before the show. I do them all, capture right there on the spot, save it, and then put it in the archive, but put it all here together. Okay. So the date on it is the date of it, just so you know. All right. So these are also the phi index and all of that, and the solar flare, which I'm not going to go into. But you see right here that this is below. It's below the alert threshold of where, you know, it's fairly calm, right? I mean, relative to what I've seen on that. This is the electron flux, which you're seeing here. Boop. All right. So these are not very active. So when those are active, you get something from Tomsk, which is the Russian site, and Tomsk is more susceptible to the solar radiance than this one is. The Italian station is. The Italian station is set up for measuring VLF earthquakes. Okay, so they're just two different stations. The Russian station does a different purpose, has a different purpose. It does exclusively Schumann resonances, where this is measuring the range of VLF up to 15,000, which is well beyond Schumann resonances. All right. So, all right. So while I'm here, I'm just going to go over a few of these guidelines. All right. So this is the second part. I went more in depth about the teaching model, and I'm just going to go in depth. I'm going to review these 5 lessons here, and then I'm going to close out the video. And then there's going to be another one on top of this that's more in depth. I'm going to go more, again, I'm just going deeper and deeper. I'm going more in depth on this one particular topic of Cumiana and the earthquakes. All right, so where I'm talking about here, this is just a preview, actually, of where I'm going in the next lesson, where we're going to be talking about, all right, let me see if I can, all right. Actually, hold on. Scoot me out of the way here. All right, good. I'll put me as a little talking head. All righty. Nice, nice. All right. I'm just kind of lining this up so it all fits in. All right. Okay, all right. All right, so, all right, so the lesson, oh my God, I can't believe I did that again. Actually, hold on. I'm fiddling with this. I should probably pause this while I'm fiddling with it, but I just want to say that the lesson, this video lesson is actually over. And so what I'm doing right now is I'm going to go into the preview of what I'm going to be talking about, the following successive video to this. I'm going to make some coffee, then kind of get everything rolling for the next video. And by then the sun should be up because it's close to 4 o'clock in the morning here. All right. So, all right, where am I? Okay. So now that I think that looks pretty good. All right. So, okay. I'm looking for my cursor. This is driving me crazy. Where are you? Are you there? Hello? Yeah. Okay, there you are. All right. All right. So, basically, like we said, it was that that you could see a peak, the red. You got to remember they're giving you the color. It's not just the red. They give you the peak of the red. Oh yeah, I caramba. All right. Where am I? All right. So they're giving you this peak of red. It says, oh, the Schumann resonant, the Schumann resonances hit 6,000 hertz, and they're looking at the red. And meanwhile, you see this column, right? This column that goes off the chart, literally off the charts, right? Another column here, this column here. They're not looking at that as part of the the data, the important data. It's just it's white. It's red is more important. That's what they're thinking. But all of this is a data spike. All of this is kind of equally as important in its own way, right? And what this is this is a different way of looking at the modes of Tomsk, okay? So I have pointed this out before, that you can see it better here on this than you can at the top with the Tomsk one, and for some in that particular respect of being able to visualize the mode based on the red and the white, and it's not all kind of blended in. All right, if that all made sense to you, hopefully it did. All right. If not, stick with me, and hopefully it will make sense to you soon. All right. Okay, so what we're going to look at, because these are the basic these are basic rules of observing the Schumann resonances, and there's not a reason to say, oh well, you're not at that point now, because these are the basic guidelines of this. All right, so of understanding the Schumann resonances. So the first one is and I have these kind of numbered by what I feel is the most important ones first, the most substantial ones first. And the first one is know the local conditions at the time of the reading of the Schumann resonances. Okay? What was going on over there? Was it a windstorm, rain, hail? Okay, was it an earthquake? What were the local conditions over there? Number two, the second guideline is that they have a limited range of sensitivity. Okay. So that means that outside of a set range, the readings you get are not going to be as dependable as the ones within that range. Okay? So generally speaking, the effective range at the most of even the best antennas are like 5 kilometers. Okay. So guideline number 3, the Schumann resonance detectors are sensitive instruments which are subject to local interferences around the machinery. Okay, and by that I'm saying the detector machinery. So we have already gone over where the antenna operator and maintenance people have explained to you that there's local interferences around their antenna site that will show up. Tones, they call it. Okay, so tones will show up, but that's local interference. Okay, so you have heard from them that beware of local interferences. Okay, the next one up. The next one up is your results will vary depending on distance. Look at your local spectrogram to know what the local conditions of the EMF resonances. Okay, and this applies, I think, more to the ascension symptoms, the phantom symptoms that people complain about all the time. right? When they talk about, oh, the Schumann, and I'm feeling this way because of the Schumann, and this, no, it is more likely the barometric pressure. If you're looking at the data reading at Tomsk, and you're wondering why you in Hoboken, New Jersey feel that way, maybe it's the chemical plants near your house, perhaps. Perhaps it's something in the water, right? You cannot overlook local influences in your life as why you feel bad. In the same respect, you cannot overlook local interferences at the detector site as to why it's feeling bad. Okay? I've heard a lot of people look at the reading for the earthquake and say, oh, that's why I feel so bad. Right? Or that explains it. But not to me, it doesn't. That's the reading for Italy. Where were you located? I know as a fact this is only picking up Italy. And why I'm doing this and going into so much depth is because of all the confusion and the lies that are spread over Tomsk, the Russian people, how they get motherfucked, basically, that they're somehow manipulating data because they're picking up something completely different from this, when their job is to pick up. They're doing exactly what they're supposed to be doing. They're picking up the right data. These guys are picking up a different data set based on where they are here. That's why it's extremely important for me to be doing this, to explain to you the difference between one and the other in as much detail as I can, so as not to bore you, but for you to get the complete picture. Okay. So, know your local conditions for you and the machine both. Don't blame your invisible symptoms on a reading in Italy when you live next to a plastic plant or a garbage dump or something. You know, I mean, I don't know. I'm just saying, you need to do a thorough check on your local influences, and that includes in your house. That includes the EMF in your house. Okay. And then the last guideline is beware of local interferences. And that is said, I've said that before in different ways, but this is beware of local influences. So that means in all things Schumann resonance related, beware of local interferences that will give you a signal. That includes the electric trains that run at 25 hertz AC, right? That includes a meat packing plant next to the, possibly that does something that operates at 17 hertz, or some other equipment that operates at 20 hertz, or some other equipment that operates at a certain frequency that combines with another one, and then you have another resonance based on a couple different local machines, right? And then you will be confused because you haven't done any research on what is around that local, the machinery, not just the conditions at the time of the reading, right? The periodic, momentary conditions, the weather conditions, but what long-term influences are there, like, say, electric trains that are going to be running at a schedule, that are going to be giving you dotted lines or coded lines that you may be misreading as something else entirely. The intelligence of the universe when it's just the intelligence of Amtrak, for example, right? Don't get the two mixed up. Don't get them twisted. This is why we do this, right? So you're not doing a technical scrying of stuff, believing it's something altogether when it's provable. It's conclusionable that there is something else more local that can be interfering with the signal. Okay, so that's just, I think, a good introduction. And like I said, I've mentioned this before, the proper way to read this is 6,000 decibels of pico electron volts. Okay, so decibel is a power rating. Okay, And it's usually when it's a power rating and not a frequency rating, when it's a power vertical frequency, as we call it, I call it the vertical conductivity, as they call it. So when we're looking at the vertical column of energy here, right, the amplitude is pico-electron volts. So when we're talking about the strength of a signal on the amplitude, that's a decibel. The strength, the power of the signal is decibels. So when it bops up like that, it's 3,000 decibels of electron volts, which gets a hertz, a frequency rating, okay, because it's measured on that scale. Okay, so I think I'll be going into that next time. I mentioned that the last video. I'm talking more about it this video, and in the future videos, you know, I keep mentioning this, that it's decibels, it's not hertz. The frequency is decibel, pico electron volts, it's not hertz. And the frequency is the vertical frequency of the amplitude is decibels. Okay. So, all right. So this goes over all the introductory information here, over my teaching. This gives the overview of the teaching material here. So we now have almost a 50-minute video. All right. So no music. Thank you all for being here very much. I appreciate everyone for coming out. Thank you for the comments, the love, the support. Yeah, comments. That's those things. You know, if you're new here, welcome. Like, share, comment, subscribe, thumbs up, or a thumbs down. It'll still keep registering in the algorithm. But comments. I want to hear from people. Did this make sense to you? You know, it's something other than I'm hearing ringing in my ears. Please. You know, that's not what this is about. This isn't about, you know, and if you've listened to, let me put it this way. Okay, I will be honest and blunt here. If you're having problems with the ringing, the headaches, the ringing, any of your crystals are getting vibrated the fuck to bother you, ground yourself. Rather than tell me you have a headache or migraine, I'm going to respond back from now on saying you need to ground yourself. And we're going to be talking about grounding. From now on, I think, every single time I see one of those comments about a headache, my sinuses, or ringing, I'm going to ask you, what grounding regimens do you do? What purification do you do? Because the fact of the matter is, all of that ringing is because you're not doing what you're supposed to be doing. You're not grounding out those the Schumann resonances are electric. They're electrifying you. You need to ground that energy out. And until you do, there's nothing for me really to talk to you about. You need to do that basic minimum work. You can't just throw some hit and run comment on my thing, or because that's what's coming back to you. This is not ascension yet. You need to ground. There's work to do, right? Now it's the harvest time. I'm not the fun teacher here. Well, we're going on a field trip. No. There's lots of working and harvest and cleaning and clearing that you need to do, right? I'm your parent that is telling you, is your closet clean? When was the last time you did your laundry? When was the last time you cleaned your house? Maybe the headache is because you live in a dusty house and you're not getting breathing enough, right? I mean, I will be dead straight up honest with you on all this ascension shit, because it's not ascension until the harvest is done. Just straight up understand that. I don't care what anyone tells you. They haven't been through this, right? They haven't been through this. They're guessing, okay? I came back to help out. So, you can believe it. Believe what you want. You're free to believe anything you want. The easier, softer way, if you want, the love, and let's just think positivity, happy horseshit, toxic positivity, whatever you want. It's a world of illusion. Believe what you want, please. Okay. However, when it comes time to pay the accountant, pay the piper, and it comes time to get what you worked for, right? Keep in mind, I've already been through this process once. I came back to help. I volunteered to help because people needed it. It's just time, okay? So, having been through this once, I'm giving you the benefit of my, work in this. The previous work of the last lifetime, which was hard enough, and then this time, which was even harder this time. And if you want to go up in the ascension, remember, sandbags are holding you down. What are the sandbags? Fear, guilt, shame, grief. So, before you get any height, any elevation, you need to do the clearing. So, please, save me the comments on the ringing, the this and the that. I have videos on it, and all of them will tell you you need to ground the energies because it's electricity, right? If you took a loose wire and you held it in your hand, you would get electrocuted, electrified, and it is the same thing with these, that they're there holding energy, holding radio frequencies in the air at the frequency of fear and guilt and shame. That's what the Schumann Resonances are doing. They're not rising. They're not umbilically hooked to the frequency of the planet. The frequency of the planet is operating at 10 to 11 hertz, roughly. It's vibrating at that, okay? The Schumann Resonances are caused by the light bouncing around the Earth in the isolating cavity a few times, okay? And at that point, once it bounces around and around and around, it becomes a density, it becomes a gravity that's held intact at the 7.3 to 8.0 hertz frequency. It ain't going any higher than that, right? The fundamental that makes up the Schumann resonance is 8 hertz, right? 8 hertz is not the frequency of the planet. The planet is 10 to 11. Right? The threshold, cutoff threshold for fear is that 10 hertz, magic 10 hertz mark, right? If you can vibrate over the 10 hertz, you're low, the lowest chakra. If you're not operating in fear, that is the shift. You're no longer at that lowest that is held intact by the Schumann resonances. Okay, so on that cheery note, that public service, and we're almost an hour into it. All right, so with that cheery note, I'm going to end this for right now so that I can close this out and I can post this so it'll all be ready for your coffee and donuts in the morning. Alrighty, thank you all very much for being here. I very much appreciate the love and support. Like, share, comment, and subscribe, and I will talk to you soon. I don't think I'll make this as a premiere, but the next one I'm going to make is a premiere. So you'll have 2 that are pre-produced, then 1. The next one will be, will definitely be like, it'll be close to like 2 hours, I think. Or definitely an hour. I mean, this one was an hour, and I'm just getting introduced, so whatever. Anyway, all right, enough jabbering on. All right, thank you all. Much love. Bye. Namaste.